So in the previous videos, we have seen the forward checking algorithms, the one that corresponds to the filtering of the binary decomposition. And an important question is, what kind of consistency is it able to perform? Does it correspond to domain consistency? And as you can expect, it does not correspond to domain consistency. Otherwise, I would call it right array domain consistency, but it's not the case. And so let's consider one very example of an all different constraint with 9 variables. And you can really assume that it's like playing Sudoku. It's exactly one line of the Sudoku, and you have to reason on that line. So this is the current situation, and you have a number of variables that are already born. So you have this one, and this one. X7 is already born. So what can we deduce here? What you can immediately observe is that 1, 2, and 3 should be removed from the domains of the other variables. So 1, 2, 3 will be removed from here, from here, from here. And this is all what you would get by using the forward checking filtering. But you can do more than that, because what you can also see here, once you have removed 1, 2, 3, so I assume that I have removed it, that you know that 4 and 5 will be assigned to x1 or x3, but since x1 and x3 must take different values, of course you could have the solution 4, 5 or 5, 4, but it doesn't matter. You know that these two values are not available for other variables. And so what you can do is that you can remove them, 4 and 5, from the other one. So let's remove it from x5, and then you know that you have 6 here. But now, since 6 is decided for x5, it can also be removed from x6, x8, and x9, okay? And then again, we have the same situation. You know that 7 and 8 will be taken by x6 and x9. You don't know exactly which one. It might be 7, 8, or 8, 7. But what you can already deduce is that exactly like a Sudoku player would do, you can already deduce that it's not available anymore for x8, and so 9 is the one that is chosen here, right? And so this is all what you can do. If you do that, you do domain consistency. You have removed everything that you could for the all different constraint. And since we were able to remove these three variables, these three values from the variables by performing the forward checking filtering algorithm, you know that this decomposition is not achieving domain consistency. And even for small examples such as this one, the binary decomposition or the forward checking is not able to see that this is inconsistent. Okay, so you know that we have 3 variables here. In this last example, we have 3 variables, but only 2 values are available for each of them, only the 2 same values. So this is what we call a pigeonhole problems. This is not possible to find a solution for that instance, and the binary decomposition is not able to see it, because if you hide, let's say you completely hide this variable, then the not equal constraint will consider that it's feasible. Between x2 and x3 the same, and between x1 and x3 the same. So the decomposition is too blind to detect that it's not feasible. Okay, that's a problem. So in the next video, we will explain a domain consistent filtering algorithm that is able to do all the filtering that we have seen here. Okay, it's able to do all this, and it will also be able to deduce that this situation is not consistent and it's not feasible, that the constraint should fail, and as a consequence, the search will backtrack much more than with the binary decomposition for the all different constraints.